Welcome back to database-tutorials.com. In our last video, we learned how to create a table inside of a database. We also learned how to add columns to that table that had column attributes and the sparse attribute. So in this video, we're going to learn how to create an index for a table. Let's see how it looks. Hello everyone, and welcome back to the SQL Server Series. This video is brought to you in reference to Joe Marach's SQL Server 2016 for developers. If you're interested in purchasing a copy of this book, then please follow the link in the video description below. Using indexes has its pros, as an index can improve performance when SQL Server searches for rows in a table. Full table indexes index every row in a table, and each table can have a single clustered index and up to 249 non-clustered indexes. SQL Server automatically creates a non-clustered index for each unique key other than the primary key. Filtered indexes are indexes that use a where clause to filter the rows to the index. A filtered index can improve performance when the number of rows in the index is small compared to the total number of rows in a table. SQL Server's convention is to prefix index names with the characters IX underscore, and we recommend you do the same, but of course you can use any index names that you like. So to create an index, you name the table and columns that the index will be based on in the on clause. For each column, you can specify the ASC or DESC keyword to indicate whether you want the index sorted in ascending or descending sequence. If you don't specify a sort order, ASC is the default. The basic syntax of the create index statement starts off with the create word, followed by your clustered and non-clustered options, and then you code index followed by the name of the index that you want to create. And then you code the on clause to specify the table name that you're creating this index on. And then after that, you include your columns, which has the option for one or two columns there. You have column name 1 and column name 2. And within those two columns, you have the option to specify whether you want it to be in the ascending or the descending order. And then finally, you have your where clause, which will be your filter condition. Now let's create an index. And the first thing I'm going to do is reiterate my syntax for the create index statement. And so it's going to be create, and then in brackets, it's going to be your clustered option and your non-clustered option. And then followed by index and your index name. And then it's going to be on the table name that you want to associate it with. And then in parentheses, it's going to be the first column name. And then you're going to be able to include the option of whether you want it to be in ascending or descending order. And then after that, it's going to provide you with the option for a second column name. You can have column name 2, and then that one can also have the option of the ascending or the descending order, and so on if you want to include 3 or 4 or more columns. And then there's going to be your where filter condition. That's going to be your where clause. So that is our syntax. So the first example I'm going to do is you create an index statement that uses the non-clustered index based on a single column. So first we need to use our AP database. I'm going to run that statement, and then I'm going to say create index, and since I recommend it, I'm going to say IX underscore the table that I'm going to be at. I'm sorry, not the table, the column that I'm going to be using is vendor ID, and then that's going to be on invoices, and then I'm going to specify the vendor ID here at the end. Now I'm not going to include a where clause, and I'm not going to say ascending or descending. So by default, it's just going to go ahead and it's going to run it in the ascending order. So I'm going to run this index, and our index has been created. So that's how you create one using a non-clustered. So this is a statement that creates a non-clustered index based on a single column. Let's remember that. The next one we're going to write is going to be a statement that creates a non-clustered index based on two columns. Let's see how it looks with two columns. So I'm going to say create index ix underscore invoices, and then it's going to be on the invoices table, and then my first column is going to be invoice date, and then that's going to be in the descending order I'm going to specify at this time, and then my second column is going to be invoice total. And this time I'm not going to specify anything for that, so it's going to use the ascending order on its own. And then I'm going to run this. That creates that index, and we just created index name ix underscore invoices on the invoices table that had an invoice date in the descending order and invoice total in the ascending order. Now let's take a look at an example of a statement that creates a filtered index for a subset of data in a column. So a statement that creates a filtered index for a subset of data in a column. And so the first thing I'm going to do is say create index, and then I'm going to name it ix underscore invoices payment filter, and then that's going to be on the invoices table. And then my first column is going to be the invoice date in descending order, followed by the invoice total. I'm going to leave it as default for ascending order, and then my where clause is going to say where payment date is null. I'm going to create that, and that creates a filtered index for a subset of data in the column. When we're specifying the payment date is null, we're basically saying for every payment date that is null on the invoices table, create that invoices payment filtered index. So that's what that did there for us. Now my last example is going to be a statement that creates a filtered index for a category in a column. So let's start off with create index, obviously, and then we're going to name this one invoices date filter. Then that's going to be on the invoices table. My first column is going to be the invoice date in descending order, followed by the invoice total in its default ascending order. And then we're going to say, hey, where invoice date is greater than 2016-0201. And so this is going to create that invoices date filter index on the invoices table for only where the invoice date is greater than 2016 February 1st. So we're going to run that, and then that creates that index. That is all for this video. In our next video, we're going to learn how to use snippets to create database objects. So if you're interested in the next video, you know what to do. Head on over to database-tutorials.com and check it out. See you next time.